question 63. Okay, so you've got your f of x and g of x defined, and then it says in part A, by considering g dash of x, show that g is an increasing function. So when it means increasing function, it's talking about the fact then it's got a positive gradient, okay? Because increasing function means the curve of it will be sort of going up like that, right? Doesn't that, you know, it looks kind of straight, doesn't have to be that straight, but it will be going up, right? The curve will be increasing, right? That's what it means there, positive gradient. So that's why they're asking us to do g dash of x, okay? So we got g of x equals this. Now what I would do is, I would rewrite g of x, okay? Now you could look at that as a quotient to differentiate, but because it's just a constant on the top, take the x plus 1 up and put it to the power minus 1. That might be easier for you. You could do it as a quotient if you wanted to, but if you write it like that, it's slightly easier then to get g dash of x. So with that then, bring the minus 1 down and times by minus 4, so that'd be plus 4. X plus 1 then, and then take away power. Take away 1, so you end up minus 2. Times then the derivative in there, which is 1. So this then becomes 4 over x plus 1 all squared. Now, to show that this is an increasing function, it's all going to do with the domain of g. Okay, look at the domain of g, so we've got to go back up to the top. The domain of g is here, isn't it? That's the domain of g. Okay, and the domain of g is negative, I believe. Okay, negative. Okay, so the domain of g is negative because it's minus infinity minus 2. Okay, now when you look at this here, right, it actually doesn't matter what the domain is in this sense, because the top is always going to be positive. Okay, 4 is positive, always positive, it's constant. The bottom will always be positive as well. Okay, bottom will be positive. It's positive because you're squaring. Okay, x plus 1 all squared will be greater than 0. Okay, will be positive. So you've got positive on top, positive on the bottom, leads to a positive gradient, so that means g is increasing always. Okay, if g is increasing always, as I said earlier, you get a curve sort of like that increasing. That will then help us to get the range of g, because if it's always increasing, the lowest value in that range will correspond to the lowest value in the domain, and the highest value in the domain here, which is minus 2, will correspond to the highest value in the range. So if we put minus infinity to start with in, okay, to the function, so you get minus 4 over minus infinity plus 1, okay? So, you know, there's loads of minuses going on here, but you've got to realise you're dividing by infinity, so you're dividing by a massive number, that will go towards 0, okay? It doesn't matter about plus or minus there, right? That will go towards 0. Put minus 2 in, so you get minus 4 over minus 2 plus 1. So that will equal minus 4 over minus 1, which will equal to 4. Okay, so then your range will be 0, 4. Okay, that's your range of g. Okay, with 0, 4. Right, part C then, it says write down the domain and range of fg. Now, remember what I said before, okay, to this. I would actually go to answer part D first, okay? I find it easier to do it this way. So write an expression for fg. Let's do that first, then we'll go back and work out the domain and range of fg. So fg of x, as they've got written here, and remember you work from right to left, so g of x goes into f. You know, put a bracket around there, you might see that a bit better there. G of x, working from right to left, do g of x first and put that into f. So g of x is this, putting it into f. So when you deal with f then, you have square root. Now, x squared then, when you put this into that, so you get all this squared plus 5, okay? You could leave that like that, okay? What I maybe do here, just to make this look a little bit nicer, is I will square top and bottom, that's 16 squared when you get rid of the minus, right? So it becomes 16, and then you square the bottom, just put it as a bracket squared plus 5, and we job done, all right? So I've answered part D here, but I've done it in good wisdom because I can then deal with C much easier. So now with C, the domain of fg, okay, is quite simply the domain of g, isn't it? Okay, yeah, so remember that, okay, because we deal with g first. The domain of fg is always the domain of g, which is, going back to the top, minus infinity minus 2, okay? To get then the range, right? The range, you put the domain, to get the range of fg, put the domain into the function fg. That's what I would do. Okay, so minus infinity, put it into this. Okay, so square root 16 over minus infinity plus 1 all squared plus 5. Now this looks kind of messy, but don't worry about it. You've got infinity here on the bottom. 16 divided by infinity is 0. 16 divided by massive is something is 0. So that's 0 there, plus 5 then, so that's going to be root 5. Okay, that's what it is. Leave it as root 5. Put then minus 2 in. So 16 in here, minus 2 plus 1 all squared plus 5. That leads to, if you work that out, that'll become minus 1 all squared, so that's 1. 16 over 1 is 16 plus 5 is root 21. Okay, so that's what it is there. The range will be root 5, root 21. Okay, and just to be clear then, the domain is probably right next to each other. Minus infinity, minus 2, that's for fg. Okay, so part D then, question 1, it says then, write down an expression for fg. Well, you can just say C above. Okay, we've done the workings out up there. And of course you've got the answer. I would write the answer out again. Fg of x is equal to this. Okay, then last bit, it says then solve the equation when it's equal to 3. Okay, so this equation Fg of x when it's equal to 3, well 3 is just the line y equals 3, so it's like simultaneous equations. So basically when this is equal to 3, okay, so we'll put this equal to 3 and we will simply set it out like this. Okay, and what I would do here handily here is, because you're square rooting the whole thing here, take the square root over and square that side. So you get 9, yeah? Take the 5 over. So take the 5 over, it becomes a subtract, so that becomes a 4. Swap these around, yeah? Swap these around, take the 4 down there, take the x plus 1 squared up. So you get x plus 1 all squared equals to, well, 16 divided by 4 is 4. So then you've got to do, well, you can take the square over. Take the square over now and square root. When you square root 4, you get 2, but it's plus or minus 2. Okay? And then we've got to decide what's it going to be. Okay? Well, we could have both answers, right? But, you know, let's see what both answers would be. If we take the positive, we'd have x plus 1 equals 2. So that means x would equal 1. Or x plus 1 equals minus 2. So that means x would equal to minus 3. So you've got two answers there. It doesn't necessarily mean that both answers work. You've got to go back to the range then, okay? You've got to check the, you've got to go back and check the domain, because remember now, we put fg of x, yeah, equals to 3, fg of x equals to 3, and the domain is that, okay? So the domain is minus infinity minus 2 of fg of x. So those are the x values we can have, but if you notice here, this is outside. X equals 1 is outside the domain, okay? So that's no good. So that means x equals minus 3, and that it will be in there, so that one will work, and there's our solution.